Okay, so we were discussing the achievement, right? That is some place in Mendeleev's periodic table, some places were empty, and in this empty place he had written the name as Ika and the name of the preceding element. So in place of scandium it was as Ika boron, the preceding element was boron. In the same way, in case of gallium, it was written as Ika aluminium. That is, these empty places were named as Ika before the preceding element. That is, the element which is preceded by this element, that element's name is written, and before that just Ika is written. So Ika boron, Ika gallium, and Ika boron, Ika aluminium, and Ika silicon. Later on, when scandium, gallium, and germanium were discovered, then it was seen that this scandium is showing the properties as that of boron, and the same way silicon, Ika silicon, right? Ika silicon is showing the property as that of germanium. Then these places were can be filled up, or it was filled up by this scandium, gallium, or germanium. So this is a big achievement, because you see at that time he left these places that some elements will be discovered later on which will show the same property as that of this particular element. He predicted it, but later on, when after discovering of these elements, they can be placed in his table. So this was one more achievement. Suppose you see in case of that is Ika aluminium. Okay, so the atomic mass of Ika aluminium he predicted as 68. Okay, but the atomic mass of gallium is 69.7. Again, formation of oxide, formation of chloride. You see, these are what? Matching. That means what? The prediction of Ika aluminium in Mendeleev's periodic table is nothing but what? Gallium. This was one more achievement. And the third achievement is that in his table, at that time these noble gases were not discovered, and after the discovering of noble gases, in his table, as noble gases can be placed in a different group, so there will be no disturbances by considering these noble gases. That is, noble gases will not create any trouble in Mendeleev's arrangement of periodic table, because as they can be separated, they can be placed in a different group, so no problem with this Mendeleev's periodic table. So these are the achievements. Now again, so many limitations are there, right? Now the first limitation is the position of hydrogen is not fixed, because you see in if we look at Mendeleev's periodic table in his point of view, then you see two things are there. And the first way, you see that if we look at hydrogen in a point of its electronic configuration, in that point of view, then this hydrogen, it is matching with, you see, lithium, sodium, because they are having one electron in their outermost shell, right? So as that means from this electronic configuration we can get an idea there that hydrogen is matching with lithium, sodium. That is, hydrogen is showing the properties of lithium and sodium, or they can be placed in a same group in this point of view, right? Again, you see, if we look at the reaction with that is chlorine or halogen, then if hydrogen react with halogen, it form what? HCl. In the same manner, if sodium react with halogen, sodium chloride. If lithium, then also what? Lithium chloride. That means what? It is showing the properties as that of lithium and sodium. From this particular point of view, or from this particular concept, we can say that hydrogen, lithium and sodium can be placed in the same group. Besides this, if we look at hydrogen in a different sense, or in a different point of view towards the formation of diatomic molecule, you know, hydrogen can form what? H2, right? Now you can see chlorine can form what? Cl2, fluorine can form F2. So in that point of view, formation of diatomic molecules, and if hydrogen react with there is a metal, then or non-metal, that is they can form what? Covalent compound, right? Now if we see in that particular point of view, then we get the idea hydrogen is actually showing the properties of chlorine, fluorine, that is showing the property as chlorine, fluorine show. So if we consider this formation of diatomic molecule or formation of covalent compound, then hydrogen should be placed in the group of chlorine, fluorine, or in their group. So there is a big problem or a confusion was there where the position of hydrogen will be, or in which position hydrogen can be placed, because chlorine, fluorine, they are in the different group, and lithium and sodium are placed in different group. You see here in this table, lithium, sodium, they are in this group. Again fluorine, chlorine, they are in the different group. So hydrogen is showing the properties of fluorine, chlorine also in one sense, and in other sense it is showing the properties of lithium and sodium. So there was no fixed position for hydrogen. Next problem is that you know that in his time isotopes were not discovered. And what is isotopes? The elements having same atomic number but different mass number. Again you see in Mendele's periodic table what we have observed: increasing order of their atomic masses, right? So when isotopes were discovered, same element, suppose you see if we consider the isotopes of hydrogen, then you know hydrogen having 3 isotopes, right? That is one. Right. Now if when hydrogen, suppose hydrogen having 3 isotopes, or if we can consider suppose carbon, we know carbon has 2 isotopes, carbon 12 and carbon 14. Now same element carbon, but as two forms of carbon are available, carbon 12 and carbon 14. So atomic mass is different but the same element. So if we want to place them in Mendele's periodic table, then we have to place in suppose in one box carbon 12, another box carbon 14, but it is not seen in this manner in his table, because here 12 carbon 12 the same place is given. So this was a great challenge for Mendeleev, that when isotopes were discovered, then isotopes could not be placed in his table according to his law, because his law was on the basis of though physical and chemical properties are there, but a trend of increasing atomic mass is seen in his table. So isotopes, they show what? Similar chemical properties, but their atomic masses are different. So how can we place them in a same group though they are showing the same properties but their masses are different. This is one more problem or one more limitation of Mendeleev's periodic table. And the third one is there is no regular increasing trend of atomic masses. You see, suppose sodium, after sodium atomic mass 22.99, again magnesium 24.31 is shown again. So difference is what, suppose not 2, right, less than 2, but here you see difference is almost more than 4. So there is no fixed trend of, or there is no regular increasing atomic masses. So it was a great problem, or it was a great challenge for the other scientists to place the other elements or to know how many elements can be discovered in between two elements, because in his time only 63 elements were known. Later on so many elements were discovered. So in his table there was not exact any idea, or from his table nothing is revealed regarding the concept or regarding the fact that in between two elements how many elements can be placed. If there is no fixed trend of increasing atomic masses, then how can we know that, or how can anyone will be able to detect it, that in between these two elements this many number of elements can be discovered or they can be placed. So as there is no regular trend, there is no fixed trend, or there is no fixed difference, suppose 2 or 1 or suppose 0.5. If it was mentioned that in between two elements the difference in atomic mass will be suppose 1 or 0.5 or 2, then whenever we will see there is a gap of there is a difference of atomic mass is 4, then at least we can get the idea, or the scientist could be able to place 2 more elements or 1 elements in between them. So it was not observed. So this was one more limitation. So this is all about Mendeleev's periodic table.